Hello everyone. Today we are going to discuss about the chi-square test. Chi-square test is a statistical way of testing a hypothesis. If you are going to test some hypothesis, so to test that particular hypothesis, we use the chi-square test. So what type of the hypothesis we can use to test the chi-square test? We can use chi-square test as a test of independence, test of goodness of fit, and to test the homogeneity, or we say that for comparing variances. So if we want to compare the variances, we can use the chi-square test. If we want to test the goodness of fit or test the homogeneity, we can use the chi-square test. Or if we want to test the independency, that our data is independent or not, so on that situation we can use the chi-square test. Chi-square test can be used on both type of the data. Parametric chi-square test, in this case the data type is a numerical. It means if the data type is numerical, so that particular test is called as a parametric chi-square test. So this parametric chi-square test we use test for comparing variances. Let's test for comparing variances. You have one manufacturing company. In that company you are producing some XYZ product, and you know that the product have some variance. You are manufacturing the towel, and we can say that the length could be vary from 0.1 to 2 inch. We can say that length of the towel can vary from 1 mm to 2 mm. So there is a variance, and this type of the variance has been observing from past 4 to 6 years. So now you want to test that whether still you are getting a same type of the variance in our manufacturing unit, or the variance has been increased or decreased. So you want to test the machine performance, whether the machine still are performing in the same way or not. So these type of the problems we solve by using the parametric chi-square test. So this is also called as a test for comparing the variances. So formula is that chi-square we denote by this particular sign, that is equal to n minus 1 s square divided by sigma. So s square is your sample variance and sigma is your population variances. And second type of the chi-square test, non-parametric. So non-parametric means we use chi-square test to test the categorical variables. If we have a categorical variable, we can use the chi-square test. So in which situation we can use chi-square test for categorical variable? If we want to test the independency. We have some data set, and if we want to compare the whether those categorical variable have an independent or some have some dependency. So to check that particular dependency or independency, we use the non-parametric chi-square test. And the second type of the test of goodness of fit. If we want to test the goodness of fit, in that case we use the non-parametric chi-square test. We will discuss both things in a second slide. The formula for the non-parametric chi-square test is summation observed minus estimation whole square divided by estimation. Observed, this is your observed value, and this is your estimation value, and this is your also a estimation value. We will discuss by using one example in a later slide. There are some properties we have in chi-square test. Observations are collected on random basis. It means whatever the observations or whatever the samples we collect, those should be collected on a random basis. All items in a samples must be independent. And third one is sample size should be more than 50. Parametric chi-square test, as we had discussed how we compare the variances in numerical data. Parametric chi-square test, this we use to test for comparing variances. Let's explain by one example here. The variance of a certain size of the water pipe produced by machine is 7.2 over a long period of time, and a random sample of 20 pipes gave a variance of 8. It means we randomly selected the 25, and those 25 are giving the variances of 8. So we need to check if the variability of the pipe has increased at 5% level of significance, assuming a normally distributed sample. So in summarized way, there is one manufacturing unit which is producing the water pipe, and those water pipe have a variance 7.2 over a long period of time. Now what we did, we just collected the 20 pipes and we measure the variances. Now we are getting the variances of 8 by using the 20 samples. So we need to check by using the 5% relative significance that there is a variability of the pipe is increased or decreased. So we need to check that. What would be the null hypothesis? So null hypothesis would be population variance should be or less than 7.2. It means our variance should not be greater than 7.2. And alternate hypothesis would be population variance should be greater than 7.2. So what is the formula for parametric chi-square test? Equal to n minus 1 s square, it means sample variance, this is your population variance. So 20 minus 1, total samples is 20 minus 1, s square is your samples variance. Sample variance we have 8 because we collected 20 pipes and we observed that variance is 8. So x square is equal to 8, and this is your population variance. Population variance is 7.2. So we mentioned the 7.2. So after calculating those things, we are getting the chi-square value 21.11. So chi-square test value we are getting 21.11. So we are getting chi-square test value 21.11. And what is the significance level? Significance level is 5%. So what would be the value of alpha? Alpha value would be your 0.05. This is your alpha. So we need to test. And what would be the degree of freedom? Degree of freedom is n minus 1. So n is 20 minus 1, it is 19. So we are getting degree of freedom is 19. So we need to test the chi-square value at significance level. It means we have to test the chi-square value at 0.05. So this we can check by using the chi-square table. So let's check chi-square value at 0.05. So this is the table. So here you can see that 0.05. This is your significance level, and degree of freedom is 19. So 19, you can see that this is your 0.5. So we are getting 30.14. So we are getting chi-square value, we are getting 30.14. It means if we draw here, you can see that at a critical level, this is your chi-square value at critical level. It means this is your critical area, critical region. And what is the test value of chi-square? 21.11. This is your 21.11. It means our test value of chi-square is coming under the acceptance zone. So we will accept the null hypothesis. It means we can say that there is a no variability. It means whatever the pipe variance we have been getting from over a long period of time, we are still getting a same variance. There is a no change in variability. So this way we can test the variances by using the chi-square. And second type of is the non-parametric chi-square. It means we use on a categorical data. Non-parametric have two types: test of independence and test of goodness of fit. Test of independence means we test whether two categorical variables are independent or not. Let these are the two categorical variables. So we can check whether these two categorical variables are independent or not. That this is your population. In this population there are 6 to 8 categorical variables, and we selected one samples. In that first sample is that, second sample is that. In that sample we have categorical variable X. This is your categorical variable Y in the second sample. So how we can check that these variables, these both are independent or dependent? These variables, these are the two samples. So we can check whether these two samples are dependent or independent to each other, because these are the categorical variables. So we can only use the chi-square. And the second one is the testing of goodness of fit. So we want to test or prove that how closely my data is with population data. This is your population and this is your sample. You collected one sample. This is your categorical population. This is also your categorical sample. So how we can check that how closely my samples is with population? So here it is saying that how closely my data is with population data. It means how closely my sample is with population data. So this is called as a goodness of fit, or we can say that how closely the distribution of the categorical variable match with expected distribution. This is your observed value. I observed that he is a good boy, and our expected value is that he is not a good boy. So how closely my this particular data is with this data. So this type of the comparison of the categorical variable we can use by using the chi-square non-parametric test. So let's understand by one example this. A survey conducted by Government House Department that 60% of flat owners only have one flat, 28% have two flat, 12% have three flat. So these all are your estimated value. Now, but some organizations are not convinced by the survey. This particular survey was done by the government organization, but some other organizations are not convinced with the survey which was done by the government department, and they decided to conduct their own survey. So they found that, it means this is your observation, they found that out of 129 flat owners, 73 has only one flat, 38 has two flat. So now we need to check that survey data support with the government data or not at 95% confidence level. It means we have two data set. Okay, this is your observed data set, this is your estimated. Estimated means this is your government department data. Government have done some survey, on that basis they estimate some data, but some other survey team is not convinced this particular data. So what they did their own survey, and on that basis they observed some value, let x, y, z. Here we also have x, y, z, three value. They also collected the same variables data. Government department also collected the same variables data, but the value inside those categorical variable could be same or could be different. So we need to verify that how closely this particular observation is with estimation. How closely my observation is with estimation. So we need to check that particular thing. Here you can see that our null hypothesis would be observed data should be equal to your estimated data, and alternate hypothesis would be observed data should not be equal to your estimated data. So here our observed data, first one flat we have 73 has one flat, 73, two flat has 38, so 38 people have two flat. So remaining to 129 minus these we need to add, then subtract in 129, then we'll get the 18 people have three flat. So this is your observed data. So now we will calculate the estimated data. Estimated data means one flat. One flat means this is total population is 129 and 60% flat owner have only one flat. The 129 multiplied by 60 divided by 100, then we will get 77.4. 4 people have one flat. In the same way we can calculate the remaining one. It means 36.12 have 2 BSK flat, and there is a 19.48 has 3 BSK flat. Sorry, 15. This is your 15, I think. So we have, this is your observed value, this is your estimated value. So now we need to compare that our observed value is equal to your estimated value or not. So how we will do? We will use the chi-square non-parametric formula. Summation of observed minus estimated whole square divided by estimated. So observed value for the first one 73 minus 77.4 whole square divided by estimated. Estimated is your 77.4. So this way we can mention all the things here. After calculating we get chi-square test value 0.75. So this is your test value. Now we need to test the chi-square value at confidence level. It means your alpha would be your confidence level. It means your confidence level is 95%. It means your alpha would be 1 minus 0.95. So that would be your 0.05. So alpha we are getting 0.05, and degree of freedom, total number of samples and 3 minus 1 is equal to 2. So degree of freedom we are getting 2. So we will use the chi-square table to test the chi-square value at a critical level. So at 0.05 and degree of freedom 2, we will check the, now we will calculate the chi-square value at critical level and degree of freedom. Here you can see that 0.05 and degree of freedom is 2. It means we are getting 5.99. So here we are getting chi-square value at critical level 5.99. If we draw these things here, you can see here, this is your critical level, this is your critical value, and this is your test value. Test value we are getting 0.75. It means it is coming inside the acceptance zone. So we will accept the null hypothesis. It means our observed value and estimated value are almost close to each other, and this is called as a goodness of fit. So that's it for today. If you have any query or any suggestion, you can mention in the comment section. I will try to answer all of your query. I hope you will like my video. Thank you very much for watching my video. Have a nice day.